Hello to everyone. Myself is Dr. Vadiraj Thango, Assistant Professor, Shichikadguru Tondadari Government First Grade College, Mundagi. So in this session, I am going to deal with the crystal structure. This is for BSc program, Physics for BSc 6th semester, in paper number 1, concerns to Karnataka University, Dharwad. And this session I am concentrating my discussions towards the lattice, translation vector, and unit cell. And learning objectives for this session is to know the concepts about the solids, to understand the concept about what do you mean by crystal structure, what do you mean by lattice, and what is the uses and how the explanation about the translation vectors, and exactly what is unit cell. And overall, the session outcomes for today's discussion is to understand the solids, about what do you mean by crystal structure, idea about the translation vectors, and clear picture about unit cell and lattice. Prerequisites for today's discussion is to know about solids, liquids, and gases. As we know, solids are perfect size, shape, and everything. Liquids have the mass but not shape. Gases does not have the mass, shape, anything. So solids having mass, shape, size. Liquids having mass and does not have perfect shape. It depends shape depends upon its container. Gases does not have mass, size, shape, everything. And we should know what do you mean by what is the chemistry of solids, idea about the crystal and amorphous nature in the chemistry classes. As we know, solids solids having definite mass, shape, and size. So these solids can be classified depending upon based on their atomic arrangement into crystalline and amorphous. Exactly, crystalline solids are atoms are arranged in orderly manner like iron, copper, NaCl, that is sodium chloride, and metals. Amorphous solids atoms are not arranged in a periodic manner or in a regular manner. Example belong is glass. So as you know, to define the crystal structure, we should understand two concepts. One is called lattice. Another concept is called basis. So lattice means, see here, these are the points. First point, second point, third point, fourth point, first row, second row, third row, fourth row, in this way. Columns, first column, second column, third column, fourth column. So in this way, the points are arranged in a perfect manner, or in a regular manner, or in a periodic manner. Such kind of a arrangement of points in a space in a periodic manner, a regular manner, or in a systematic manner, such kind of a arrangement of a points in a space is called lattice or space lattice. So how the and another concept is called basis. The fundamental, suppose if these lattice points is a purely geometrical concept, does not connecting with any physical ideas. So if these lattice points may contain atoms or group of atoms, it repeats itself in a periodic sense. Such kind of a things are called basis. So this basis is physical manner, but periodic arrangement of a points in a space is called lattice. It is not a physical manner. So now we want to define what is crystal structure. So see here, the lattice is periodic arrangement of a points in a space. If you attach atoms, it becomes periodic structure. It is called crystal structure. Therefore, crystal structure can be defined as, see here, periodic arrangement of a points in a space. So this is base attachment of a lattice point with the one atom. It becomes lattice points. They are the black spots. Red spots are the atoms. Therefore, lattice plus atoms collectively called as crystal structure. Therefore, crystal structure can be defined as lattice plus basis. Lattice plus basis is equal to called as crystal structure. Therefore, whenever you want to define what do you mean by crystal structure is lattice plus basis is called crystal structure. Now, we want to explain what do you mean by translation lattice factor. Suppose this is one of the lattice. This lattice having x-axis, y-axis, z-axis. This x-axis, y-axis, z-axis are represented by unit vectors called u, v, and w. The unit vectors along x-axis is a, along y-axis is b, along z-axis is c. It can be represented by a vector called vector t is equal to ua plus vb plus wc. It is called translation vector. So, and right hand, if they are suppose translation vector is rotation of a vector, identical lattice point in three-dimensional lattices can be represented by like this. Translation vector or lattice vector UVW are integers. Therefore, rotation of a crystal by itself is called translation vector. Next concept is cell and lattice. So lattice is a periodic arrangement where points in space. If we attach the atoms or group atoms with the lattice points is called crystal structure. Suppose in this figure, this is one complete lattice, and see here the blue marked area is the smallest geometry. It repeats its geometry is a building block of the whole the crystal. The characteristic property of the whole crystal is just a building block of this blue lined unit cell. So this small area is called unit cell, or it is also called primitive cell. Primitive cell or unit cell can be defined as it is the smallest geometry. It represents characteristic property of the whole crystal. Such kind of a smallest geometry, or it is also called minimum volume cell or unit cell or primitive cell. Such a kind of a cell is called unit cell, and it is the characteristic property of the whole crystal. Therefore, we have defined what we mean by unit cell. Therefore, unit cell is the smallest geometry. It represents characteristic property of the whole crystal is called as unit cell. Some few multiple choice questions connecting with today's discussion we can define. So lattice is periodic arrangement or non-periodic arrangement. Answer is exactly it is a periodic arrangement. Answer is A. Examples for crystals is sodium chloride, copper, zinc, all of the above. Right answer is D. That is all of the above. Crystal structure is A. Lattice, B. Basis, C. Lattice plus basis, D. All of the above. Answer is C. That is lattice plus basis is called crystal structure. So